Hello, so I think this is recording. I'm going to double check though. Okay, it does say it's recording. So one of the students asked me to work some of these problems. This is 10.2, and it can be quite confusing because it has all the exponential rules, radicals, and lots of different rules and scenarios. So it's a little bit tough, that one. That's why you have 30 questions. Some of them are really short, but it's just using old rules, combining them with new rules. This is connected to chapter 4, where we had first talked about the exponents and polynomials. If you hear a lot of stuff in the background, my son is watching a cartoon, but that's the only way I can do this today. So you're just gonna have to block that out. So the student sent me several questions. I'm gonna answer them all. So here's one, for example. And this is number 7 in 10.2. It says use radical notation. And this here, over here, I already wrote it down. This is radical notation, where you have a root, and this thing is called your index. And that's, of course, the m is your exponent. So the nth root of a to the m is the same thing as the nth root of a quantity to the m. Sometimes it helps to pull this m out in order to simplify. Sometimes it helps to leave it under. So it just doesn't matter. It depends on the problem. So let's look at this one here. All it wants is you to use radical notation. So they're not asking you to do much. And then you're just going to say, well, the key thing is when you have an exponent, the radical notation on that one is this. Or you can turn it into that. But the key thing is to memorize that. The denominator is always your index. So that is key. Always your index. So when I write this thing here in radical notation, I could apply the exponent to each one using old rules. And this is the problem with this whole section. You can do this so many different ways. You know, you could say, hey, I'm going to use chapter 4 rules. Everything inside gets that exponent. But in this case, that doesn't really help you. So let's just turn this into, the whole thing is taken to that power. So we have the 5th root, because that's this guy here, right? That's that guy. So the denominator of that fraction is always your index. Index is the thing, the nth root, whatever. And then we put the 5x there, and then that thing is taken to the power. So this would be already done. This is technically, it's completed. Or the computer should also accept the 5th root of 5x, all of it to the 4th. So sometimes both of those answers are perfectly fine, but sometimes you want to leave it under. Sometimes that helps you to simplify, and sometimes it helps to pull it out. So depending on what other problems we have, we'll look at that. Now let me change color. I'm going to do number 8 here. So, and then I'll start a new screen. Number 8 was the same instructions. That's why I didn't want to rewrite those, but it was 6x plus 5 quantity to the 4/5. So they're pretty redundant with that exponent, but it says use radical notation. So this is an exponential form, just like the first one was, the number 7. So what you do is you say, well, I got to make it look radical. And then we put the index is always the denominator. So we're going to put that 5 in here. And then we have a 6x plus 5. And we have that to the 4th power. And again, that's all it wants. Or again, you could make it look like this. And all of it to the 4th power. So both of those are perfect answers. Okay, so let me clear the board. And then we're going to start the next one. I was asked about number 13. And this is, like I said, this section is hard because it's very confusing and there are so many things going on. Okay, so this is, negative exponents are really hard for people. We need to remember a few things. I'm going to show you an example here. I don't know, a to the negative first or negative second. Let's make it to the negative second. B, c to the negative third all over, and let's put a 2 here, and let's put 4 to the negative first here, and let's put, I don't know, k squared. So what I want you to remember here, when you see negative exponents, they have all these rules, you know, a to the negative n is 1 over a to the n, or they have a to the negative n over b to the negative n is a b to the n over a to the n. And actually, what I want you to remember is this. An exponent always goes with what it immediately touches. So I'm going to erase this stuff because students struggle with these. And we're going to write down a few things. Whoops, I might need a pen. Why isn't this going to the pen? Exponent. Just like in the past, it affects only what it immediately touches, okay? So some students, sorry, you'll have to bear with me here, touches, and my handwriting is terrible, especially when I'm in a hurry. And then if it is negative, if the exponent is negative, I want you to move it. And I'm not saying move the exponent. I'm saying the thing. And I can't call it a term because terms are separated by pluses and minuses. So we have to be a little bit careful. And then the last thing is your answer can never have a negative exponent. Okay, simplified means don't show a negative exponent. So these are 3 little things that you would get out of an on-ground class that are very helpful in this section. So as far as we're going to deal with this on the left here in a few minutes, think of exponents as attitudes. This is what I tell students that really helps them. Let's look at this one here. You're going to think of exponent as attitudes. That 2 is technically holding a 1. That a is holding a -2. That b is technically a 1. That c is holding a -3 right now. This 4 is holding a -1. The m is technically having a 1. It has its own exponent, right? And then the k has a 2. So these are all my exponents. Actually, undo. Can I do undo? Yeah. And I really wanted to only circle the ones that have a negative exponent. So sometimes in class, students get confused and they say exponents, they see one negative exponent and they want to flip everything, and they say, oh, when I have an exponent, I flip it, you know, because they see that this rule here, and then yes, it is flipped. But the thing is, it only moves. The thing that moves is the thing that has the negative exponent. So this one up here, do I have a pointer? Yes, I do. This thing here, this has a negative exponent. So I'm going to say this is a guy. He has a bad attitude because exponents are attitudes. So he's upstairs right now. Let's put him in the basement, and that will straighten out his attitude. This always works. This guy down here, or girl, has a bad attitude in the basement. So we're going to move her upstairs and make her happy. And if you do it this way, I promise they'll all work. It's the easiest way to do it. So on this first problem here, what do? Well, that 2 is happy upstairs. If he has a positive attitude or a positive exponent, he stays, okay? So he stays. That 4 downstairs, though, has a -1. So we're going to say, well, bad attitude, let's move it upstairs. And this is all multiplication. So this is technically one big ugly term, you know, so don't get confused. Don't call that different terms. Then you have A's. You have an A to the -2 upstairs. It is a negative attitude, so we're going to move him downstairs and his attitude straightens out. The B can stay upstairs. He's happy upstairs. And order doesn't matter when you're multiplying anyway. The C is unhappy upstairs. Let's move him downstairs. The M is happy downstairs. He stays downstairs. And the K is happy downstairs. It stays downstairs. And see, now all your exponents are the way they need to be. And then you just simplify. So 2 times 4 is hopefully 8. And then you have, there's really nothing you can do. Now, if you have like bases, you would continue simplifying. You know, we'll do that here in a few minutes. Okay, so you see, that's how it works. So think of exponents as attitudes, and you only move the item that has a negative attitude. And remember, exponents only affect what they immediately touch. So on this one, that was the actual number 13, what happens is people move that whole 5x to the -2/3, and they move that upstairs. And that is incorrect because that 5 has its own exponent, you see? The 6 has a 1 as an exponent, and the 5 has a 1 as an exponent technically. So 6 stays upstairs, 5 stays downstairs, and then the only thing that moves is the x, and we're going to straighten out its attitude. And that's all there's to it. This, whoops, ugly. This is the final answer, so that's all it is. Or you can rewrite it. I prefer this, actually. You know, this x is also technically in the numerator, so I would prefer it to look like this, but either one of those is fine. So let's do another one. That was number 13. Now let's look at number 17. This one's interesting. Same thing, but if you paid attention to what I just did in both of those examples, you should be able to do this one. And then you'd have to know your other basic rules. Okay. Another thing is a negative exponent never makes a negative term. The problem with this one here is that this is also a negative, but that doesn't, those don't cancel each other. Don't get that confused. Here, let's use some basic math. When you have negative exponents, the first thing you do is you straighten out those attitudes. So I'm going to keep that b to the quarter upstairs, that first one. And then I'm going to keep that b to the half upstairs. They're both happy upstairs, leave them upstairs. This guy down here has a negative exponent, negative attitude. We're going to move him. And I don't like putting a minus here because then you're going to think it's a term, a separate term. So I want you to remember basic math. A positive divided by negative, like this is a fraction, you know, a over negative b is negative a over b, remember? So we're just going to pull that negative to the front. And then this b to the -1/4 goes upstairs. And we technically don't have anything downstairs, you see? So you're not even going to show that. And then your final answer, well, your rules from chapter 4 were, and they might have used a's or b's, a to the m times a to the n. This is the product rule, where when you're multiplying 2 items, you add the exponents. You had this on the last test. So what would you do here? You're multiplying their like base, and all you do is add them all. So 1/4 plus 1/2 plus 1/4. And then we don't even need a calculator for this. 1/4 plus 1/2 plus 1/4 is hopefully $1. So it's just negative b to the first, which is negative b. Okay, clear. That's number 17. Number 18. So far so good with Barney. I'm not a big fan of Barney, but we had the tape, and yesterday my son says Barney is my best friend. So all of a sudden, I guess he sees it at daycare or something, because I was not going to suggest that video, but it's what's on. Hey, the teaching and manners. So not all bad. Okay, so this one here does not have any negative exponents. So what do we do with this? I don't remember what it said. It probably said simplify. Okay, so the rules from back when were ab to the n is a to the n, b to the n, and that just means everything inside gets that exponent. So isn't that then 3 to the 4th? Y, okay, and then we have a y over to the 1/20th, and I'm dealing the numerator right now. This is a combo of rules, you see. When you have something, let's use an x squared to the 5th, if you have a power to power, what do you do again? You multiply, right? So that one was x to the 10th. Well, now you're dealing with fractional exponents, not a problem. Y to the, 1/5 plus, I just said that, I'm multiplying. Don't look at that. Undo. 1/5 times 4/1, yes? Which is y to the 4/5. So this is a 4/5 here, because power to power we multiply. And now you have y's upstairs and y's downstairs. You're gonna have to simplify. Okay, all these basic rules, and then all the rules from chapter 4 about exponents, and now we have them combined with fractions. So that's a struggle usually. So I'm gonna do this over here. I'm gonna change color. B to the m over b to the n, meaning like base. You see how the y's are like here in our problem. And that is b to the m minus n, isn't it? So what do? You're going to subtract exponents. So you got to, in this case, you have a y to the 4/5 over y to the 1/12 is y to the 4/5 minus 1/12. And you guys are allowed to use a calculator. So if you have a calculator that does well with fractions, you're not going to have a problem. Let's work our way down a little bit. Y. If you want to add exponents, 1/12. When did I change that to 1/12? That was a 1/20th. Anybody wondering what happened? See, and this is why I'd like to rewind a little bit and tape over, but I can't do that. It's Barney in my ears. I'll use that as an excuse. Do you see this? I messed it up. I mess up too. I'm a human being. But you see how this is a 12, and I was just wondering, wow, this is going to be a 60 LCD, but that seems a little excessive here. So do you see how the original was 1/20th and I changed it to 1/12? So I'm going to erase that part. And, just like in a real class, I sometimes make mistakes, and I'm looking at a lot of stuff all at once. So that's my excuse for the day. Okay. And that was a 1/20th. I'm fixing it, sorry. Bear with me. Okay, so let's continue in the green. Over 20, common denominator, right? When you're adding and subtracting fractions, 20 times 1 and 1 times 1. So that one didn't change 5 times. 4 is 20, 4 times 4 is 16. So this turns into y, 16 minus 1 is 15, 15/20th. And they're both divisible by 5. They're singing the I Love You song. Okay, 20 divided by 5 is 4. I can't think. 15 divided by 5 is 3. So to continue with this problem, 3 to the 4th is 81. Your calculator will tell you. And then we have a y to the 3/4. If the problem asked you to write it in radical notation, this should be your final answer. It depends on what the problem asks, and I can't remember what that one said specifically, but if it asked for radical notation, it would simply be 81 4th root of y cubed. That's radical notation, and this is exponential. Okay, so that took forever, sorry. Let's do another one. Number 19. Hopefully by now these are getting easier and you're just bored because I'm doing this really slowly. Z to the 1/10 x to the negative 1/2. And you see they threw another negative in, which is great actually, because then I can go for it. I'm going to pause for a second because I think I need to start the video over. Pause recording. Okay, so on this one, we have a few things going on. The first thing I would do, and you can do these different ways, and that's another problem in this whole section. I would take power to power in the upstairs first. So I'm going to arrow over because I don't want to say equals, okay? We're not trying to make an equation out of this, but more steps is better. So if you take x to the 5th to the 1/10, you're taking power to power, so you're multiplying 5 times 1/10, which is 5/10, which is really a half, isn't it? But that's okay, I'll go to that again. Z to the 1/10. Everything inside gets that exponent. Then we have x to the negative 1/2, and we have z to the 1/5. Now, we're going to take that upstairs and make it an x to the 1/2 because 5/10 simplifies to a half. And then we're going to say, hey, that guy downstairs has a bad attitude. Negative exponent always means you're going to move that item. So we're going to move him upstairs, and now he has a good attitude. And then we're going to keep the z to the 1/10. And we have downstairs a z to the 1/5. Then we're going to use product rule and quotient rule. And that's that thing, like base, add exponents. So we're not multiplying these exponents, we're adding exponents because the product rule is b to the m times b to the n is b to the m plus n. Or a in the book, it depends on the book. It doesn't matter, same thing. Like base, add exponents. So it's really x to the half plus a half and a half is hopefully 1. So it's just x upstairs. And then the downstairs, I don't know yet, on the z's. On the z's, we're going to use this rule. A to the m over a to the n is a to the m minus n, because when you have a quotient, if you have a like base, you're dividing, you're going to subtract the exponents. So what is 1/10 minus 1/5, or you can look at it as the z's, is z to the 1/10 minus, oh, this could be interesting if you use that rule. 5 times 2 is 10, 1 times 2 is 2. Do you see this now? And this is me using the quotient rule. So what do I get? I'm going to end up with a z to the negative 1/10. And that's technically upstairs. 1/10 minus 2/10 is negative 1/10. So this guy was upstairs though. So that would look like this right here. So then over 1. Well, if he has a bad attitude upstairs, we're going to put him in the basement. And then this would be your final answer. Hopefully that helps. Let's see, what's next? Number 24. This is in homework number 24, but it doesn't matter, it's just in general. So this is 5x to the negative 4/5 plus x to the 1/5, and then you have to be careful. Right now, we couldn't really, if this is all I gave you, there's nothing you can do with it because these are two terms and they're not like, so you can't put them together. But the problem is telling you to factor out the common factor of x to the negative 4/5. So this is a little bit weird. So I'm going to go back to the more basic stuff that you did in, chapter 6, I think you did the factoring. So let's say we have x to the 5th times 3x squared. And if I ask you to factor out a common factor, hey, they both have x squared in them. So you would say, I'm going to take that x squared, pull it forward, and then the x squared times what is the x to the fifth, and that's how you get the x cubed here, because x squared times x cubed is x to the fifth. And then, oops, I should have put a plus. Sorry, I take that back. And then x squared times what is 3x squared plus 3, right? Because this is, if you distribute it back through, you get back to the original. So this is factored form, and this is just polynomial form. So we have polynomial form, and we're trying to get factored form. So it's asking us to pull out the common factor. It's telling us what to pull, so that's not really that hard here. We're going to pull x to the negative 4/5, and we're going to say x to the negative 4/5 times what is 5x to the negative 4/5? Well, just the 5. Then we have a plus. This one is a little more interesting. X to the negative 4/5 times what is x to the 1/5? So I have to play with this for just a minute. Because we're really looking for, if you're multiplying, so technically, if we're looking at this and going in reverse, this here times this here is that one. So I'm looking at, hey, this one times this one has to be that one. So what I'm wanting is, I'm going to have to add exponents and get a 1/5 out of it. So I have to get a little bit creative here. Negative 4/5 plus what fifth, or would give you a 1/5. That's kind of what you're looking for. And I would put a 5 here. Negative 4/5 plus 5/5 is 1/5. Is that true? Because that would be, and this is not exponent, I'm just looking at fractions, adding fractions. So negative 4 plus 5 all over 5, and negative 4 plus 5 is 1. So that would give me this. So wouldn't I just have x to the first, right, technically? Because see, 5/5 equals 1. This one's a little tough because you have to get creative and think around it. But so your final answer would be x to the negative 4/5 times 5 plus x, and you wouldn't put a 1 as an exponent. Now, this is what the computer wants, I believe. However, I always say final answer can never have a negative exponent. So, you know, if I were to write this in proper form, I would have a 5 plus x all over x to the 4/5, because I would put that x in the basement. It has a bad attitude. And this is multiplication, so it's legal to do that. So, but I do believe that this is what the book wants, so you're okay here. So that one was a little weird. I agree with that. I would not put this on the test, you know, so I try to be fair and not put something really weird on the test. Number 29. And we're getting there. We only have five more. We only have one more after this. This one here isn't so bad. The next one's a little weird. Okay, so I do believe, oh yeah, the instructions for this one and the next one say use rational exponents to simplify. And chapter 10 overall is a little odd, but you're going to learn soon that if the index is the same, and the exponents don't matter, you know, this could be b to the k, it doesn't matter. But if the index is the same and you're multiplying, you are allowed to put them both under the same radical. You don't know this yet. I believe that's a little bit later in a section. But if the index matches, and you're multiplying, you have to be multiplying. You can't be doing this when you're adding. But if the index is the same, you can go under. So in this case, if the index were the same, you can go under. Well, you can't do anything to this, technically, at this point. So they're telling you to use rational exponents, and that's your key. Rational exponents means fractions. So b to the fifth root of b to the fourth is b to the 4/5, because what? My index is always my denominator. That's how I memorize it, and then I put the other one in the numerator. Times. It's b to the index is my denominator. And if nothing's there, that's technically a 1, so it's 1/9. Now, what do we know about rules? When you multiply and you have like base, you add your exponents. Well, you can't really add them unless they have a common denominator, which is 45, right? 5 times 9, 4 times 9. 9 times 5, 1 times 5. Now I'm going to arrow over. Now I have a common denominator. I'm allowed to add those together, and that's 41. Now, if it starts radical, you should put the final answer in radical form. So you're going to write, and if you could simplify this, if this were a fraction that you could simplify, so let's, for example, say, I'm going to do this off the side in green, but if you had a to the 2/8, you better not put the 8th root of a squared, because that's not simplified. You would first simplify the a 2/8 into a quarter, and then you would write it in the radical form. So it's b, the 45th root. In this case, you can't simplify 41 over 45. So the denominator is always my index. I have a b and to the 41st power. Final answer. Or you could write it as the 45th root of b to the 41st power. Sometimes that helps. In this case, it doesn't matter. Hopefully this all helps. Last one. Dinosaur train. Yeah, I feel bad, but I'm going to do something fun with my son right after this. And we already had fun this morning. Sometimes you just don't have a choice. So use rational exponents to write as a single radical. So it's the same exact thing. Now, 7 to 1/3 times z to the quarter. Now here you can't use the product rule. You see what I'm saying? The product rule is b to the m times b to the n is b to the m plus n. So you're not allowed to do that, because what do you need? Like base. And guess what? You have a 7 and a z. They're not like base. You cannot do that. So we have to get a little bit creative. Let's go ahead and put these things, let's go ahead and make a common denominator though, and see if we can work with that. 12, and like I said, if you can't figure something out, just play with it. 3 times 4 and 1 times 4. And this one actually, if I think about it, I need a rule that you don't really have yet. Because, okay, now you still, if you use rational exponents right now, you still cannot put them under the same root, or you can't write it as a single radical. You can't do anything with it. You can't combine them together. So you do need to put them back into radical, and we're going to look at it. But you need another rule that I believe is not in this section. So sometimes the books are a little odd, because that rule is that the one I brought up earlier. When you're multiplying something, you are allowed to go under if the index is the same. And do you see, that's why I created that common denominator, because I know my denominator is always the index. So I went ahead and made this happen here. Well, I have multiplication, so it's legal now for me to put this under the same root. And in a classroom test or anything like that, I would never ask you to go ahead and evaluate 7 to the 4th power, because that's 7 times 7 times 7 times 7. 49 times 49 is a big number. And I would say just leave it as 7 to the 4th. But in this case, it wants it, I believe. So we're going to have to use, and I don't have my good calculator. My good calculator with radicals and stuff is at work. I have a, this is my checkbook calculator, which I never use. You have a calculator too, so it's all good. So we have the 12th root of 2401 z cubed. And that would be the final answer under 1 radical. So I'm hoping this helped some. I know I'm kind of long-winded at times. I try to explain around. It's just there's a lot of different ways to do these and a lot of options. Just remember, sometimes it helps you to put from rational exponent to radical and use rules in order to simplify. Sometimes it helps you to put something that's radical initially into rational exponents with fractions to simplify, kind of like what happened here. Sometimes you need to use a combination of rules. So different things work different ways. But thank you, students, for asking. And I'm always happy to make a video or help out. And hopefully somebody watches this and benefits. I will see you later.